Welcome to this tutorial on the basic use of offset navigation in the Mirage F1. We will go over the fundamentals of the polar coordinate system, how to apply a polar offset as measured from a TACAN beacon, how to apply the same from an INS waypoint in the Mirage F1 EE variant, and some simple but practical examples of how to employ offsets. Hello fellow virtual aviators, we are back in the hypsophilic Mirage F1, and today we'll be looking at combining the principles we have learned regarding radio and inertial navigation with the concept of navigation offsets to help further expand the tools available to us when we are seeking locations. So it is important you have a firm grasp of the fundamentals of navigation and the various equipment used in the Mirage F1 before proceeding with this next tutorial. A navigation offset allows us to find locations which are not marked, identified, or served by the usual methods available to us, for example an INS waypoint or a TACAN beacon. They do this by taking existing waypoints or beacons and mathematically altering their perceived position using some additional parameters. In the Mirage F1, this is done using the polar coordinate system, or more familiarly speaking, a bearing and a range. For example, say we have our navigation equipment configured to direct us towards a TACAN beacon or waypoint at a known location, here marked in green. Our navigation instruments are directing us towards the known location. However, the location that we are interested in finding, perhaps a target or a final approach fix, is located elsewhere, without a TACAN beacon or waypoint, here marked in red. If the polar coordinate, in other words the bearing and range from the known location to the point of interest, is known, this information can be inputted into the navigation systems in the cockpit. This causes the navigation instruments to adjust accordingly, calculating the location of the point of interest relative to the known location and directing us towards it. We start in the Mirage F1 CE. In the CE variant, offsets can only be programmed relative to a detected TACAN beacon. In this first example, we wish to land at Al Dhafra Air Base near Abu Dhabi and have been asked to land with a straight-in approach as we would when flying an ILS landing, rather than the usual pattern approach. We will use Al Dhafra's TACAN beacon to locate the base, but want to fly towards a final approach point some distance from and in line with the runway's radial, so we can get lined up with it. For this, we will use an offset. First, let's tune to Al Dhafra's TACAN beacon on 906 X-ray to get a fix on its location. Next, we will set the IDN to display our TACAN navigation information. The white needle is now pointing towards the airbase. However, we want to navigate to a final approach point. As the true heading of the runway is 128 degrees, we want to offset its position by the reciprocal, which is 308 degrees. We also want our offset to be a sufficient distance for us to get set up for our landing. Let's give ourselves plenty of time, so we will set the offset to be 25 nautical miles from Al Dhafra. The offset is set using these controls here on the right side of the IDN. An offset is known as a vecteur additionnel in French, as indicated at the top of the controls. The values for the offset are inputted using this knob. First, setting the outer knob to the left, adjust the number in the upper window with the inner knob until it reads the desired relative bearing. Set the outer knob to the right and repeat the process until the offset distance in nautical miles is displayed in the lower window. Steering cues to the offset position are then displayed by switching the normal to offset selector switch to the right. In doing so, we can see that the needle has shifted by an appropriate angle and the range to the selected destination has changed. We can now fly to the offset position using the cues on the IDN. It is possible to combine offset techniques with other features that we have looked at in previous tutorials, such as omnibearings and ILS signal detection. By combining all the equipment available to you, the navigation capabilities of the Mirage F1 begin to open up. We are coming up to the offset location and have descended to a suitable altitude for landing, so very soon we shall switch out of vector additionnel and back to normal mode, knowing that we are now roughly in line with the runway. And that's not bad. By coordinating our turn, we have found ourselves pretty much lined up with the runway, ready for our approach. We can see the airbase just ahead of us. TACAN offsets can also be used to locate targets. A forward air controller could set up a portable TACAN beacon and provide offset bearing and range to the known location of a target from themselves. By tuning to their TACAN beacon and inputting the offset information, we can be directed towards the enemy. In this next example, our forward air controller has established their position here. A known target is located at a relative bearing of 260 degrees at a range of approximately 12.5 nautical miles. We have been told that the portable TACAN beacon is operating on channel 66 X-ray. Having detected the beacon, let's input the offset values. We can now maneuver towards the approximate location of the target in the hope of identifying its location. Okay, we have switched over to offset display on the IDN, and we are about 10 miles from the presumed location of the target, so we need to visually scan the ground. Remember that the sight head on the Mirage F1 is not a true heads-up display, so we shouldn't expect any marker or crosshair pointing out the offset's location. But I think we can see some enemy vehicles just off to the left of our center line, so let's go and deal with them. In the Mirage F1 EE, our offsets are once again defined using the polar coordinate system, by bearing and range. However, we now have two options from which to measure our offset positions, either by a TACAN beacon or by an INS waypoint. In this next example, we have been tasked with locating and destroying an early warning radar station located on a remote, uninhabited island in the Persian Gulf. We can either locate the target using an offset from the TACAN beacon at Kish International Airport, or alternatively, an offset measured from our stored INS waypoint at Dubai International Airport. Offset bearings and ranges for each have already been measured. We will first use the Kish International Airport TACAN beacon as our offset reference, which is operating on channel 112 X-ray. The Mirage F1 EE has a different model of IDN, which we have touched upon in our previous tutorials. The current navigation mode is set to RNAV-N, Radio Navigation Normal Mode, meaning that the wide needle is pointing towards the detected TACAN beacon at Kish, and the range displayed in the window is the distance to it in nautical miles. To prepare our offset, we first need to insert the offset values. This is done using the rho and theta options on the IDN's mode. Select rho using the mode selector switch. Rho represents the offset range in nautical miles. This is then adjusted using the vector additionnel adjustment switch here. We need to set this as close as we can to 34 nautical miles. The switch can be difficult to adjust, so we must be as accurate as we can. Next, we will select theta. This represents the relative bearing from the TACAN beacon. Likewise, this is then adjusted using the same adjustment switch. We need to set our theta value to 138 degrees, or as close as possible. With the offset value set, we can then display navigation cues to the offset location by setting the IDN's mode to RNAV-VA, Radio Navigation Additional Vector Mode. Switching between RNAV-VA and RNAV-N modes demonstrates the difference between the beacon and the offset's location. Okay, so we need to maneuver left and travel approximately 50 nautical miles. The offset measurements weren't 100% accurate, so again, once we get close, we will need to scan the surface in order to try and locate the island. Should the situation call for it, we can change between gyromagnetic measurements and true measurements of heading and bearing by changing this switch here. The option with the representation of a compass needle is the gyromagnetic option. Well, we have located the island. When within 10 miles we have been able to spot it from the air, even though the needle on the IDN is slightly out of place, a limitation of the estimated rho and theta measurements. Let's change over to use our INS waypoint as the cue point from which to calculate our offset. We currently have waypoint 2 selected, which corresponds with Dubai International Airport. From this reference point, the EWR on the island should be 72 nautical miles at a bearing of 317 degrees. Let's set these offset values in the same manner on the IDN. With the offset value set, we can then display the navigation cues on the IDN to the offset location by setting the IDN's mode to Nav VA, INS Navigation Additional Vector Mode. Nav N mode points towards our INS waypoint. Nav VA mode now points towards the offset location. So once again, maneuvering to fly towards the offset location, we can see that the island is directly ahead of us, and the information on the IDN corresponds to this. So just over 12 miles in front of us, and we can see the island there. It only remains to destroy the EWR. Well, as ever, I hope that was useful for you. As previously stated, the use of offset navigation in conjunction with all the other navigation tools really opens up the Mirage F1's navigation capabilities. If you are wondering, Hypsophilic describes something that operates best in high places. With genuine and especial thanks to my patrons, especially Jan11, Lakota21, Plabs, Blake Armin, Starlover, and Ben. Thank you for keeping up the support, it really is appreciated. Feel free to do the usual thing, like, subscribe, comment, and share, but until next time, virtual aviators, keep on rocking and keep on flying. This is Reiver saying, last call.